Section 8.8, we're going to look at improper integrals. Improper integrals can come in several different forms. Today we're going to look at ones that of the form a to infinity of f of x dx. And what we'll do to evaluate these, we will take the limit as b goes to infinity, the integral from a to b of f of x dx. So what we're going to do is we're going to integrate the way we normally do. And we want to plug in our numbers like we normally do. The difference is we don't have a number on top, we have infinity. So in order to evaluate it, we're going to have to do a limit. And this is the other good reason why we covered L'Hopital's rule just in the last section. Because a lot of these integrals that we're going to end up with, when we go to take the limit, we're going to end up needing to use L'Hopital's rule to evaluate. Why is there a random limit section in the middle of all these integral problems? That's right, and that's why it's really good. Or you could have the integral from negative infinity to some number b of f of x dx. And we'll do this one the same way. We'll take the limit as a goes to negative infinity, the integral from a to b of f of x dx. If those limits converge, then we will say that's the value of that integral. If the limits diverge, then we'll say the integrals diverge. The other form we're going to look at today is you might have the integral from minus infinity to positive infinity. You might not have any numbers at all. What you're going to do here is you're going to pick a number in the middle. What's your favorite number in between negative infinity and positive infinity? 0. So you're going to write this as the integral from negative infinity to 0 of f of x dx plus the integral from 0 to infinity of f of x dx. And then you'll evaluate both of those limits, both of those integrals, using the limit technique from above. And in this case, you will need both of these integrals to converge in order to say the total integral converges. How come I can do that? How come I can just pick the number 0 and split it up like that? It's two ranges. This was one of our theorems in Calc 1. One of our theorems in Calc 1 is we could pick any number in the middle and split into multiple integrals like that if we wanted to. Like, think of these as just areas. This is saying take the area over the whole real line. This is saying take the area from negative infinity to 0, then take the area from 0 to infinity and add them together. So area plus area is still area. Okay, so let's take a look at a couple of these. How about the integral from 1 to infinity of 6 over x to the 4th dx? Well, you're going to write this as the limit as b goes to infinity, the integral from 1 to b of 6 over x to the 4th dx. That's the limit as b goes to infinity. You take the antiderivative. What's the antiderivative of 6 over x to the 4th? Think of it as 6x to the negative 4. So you're going to add 1 to your power. That's going to give you 6x to the negative 3, and then you divide by negative 3. Evaluate at 1 and b. This is the limit as b goes to infinity of negative 2 over b cubed. So that's what I get when I plug in b, minus when I plug in 1, I get negative 2. What happens is b goes to infinity. Negative 2 over b cubed goes to 0. 0 minus negative 2? 2. So we didn't need L'Hopital's rule for that one. That was a real easy one. But there's an example of an improper integral which actually converges. Questions on that? Okay. The integral from 0 to infinity of x e to the negative x over 3 dx. That will be the limit as b goes to infinity of the integral from 0 to b of x e to the negative x over 3 dx. How do you find that antiderivative?
Parts.
Parts. Why parts? Because u sub doesn't work. I would need an x squared up here, so that when I take the derivative, I get a 2x down there. Then substitution would work. The thing that tells me it's parts is it's got multiplication. So what I'm going to do, just to make life a little bit easier for me, I'm going to kind of go off to the side and just work out this integral. And then I'll come back up here later and fill in all the numbers and all the other things I need. I don't want to have to write down the 0 and the b every time. I don't want to have to write down the limit symbol every time. That could be a pain in the neck. So I'll go off to the side and do that. All right, how are you going to integrate this by parts? U is x, which means dv is e to the negative x over 3 dx. du is dx. And v is negative 3e to the negative x over 3. Excellent. Because it would be e to the negative x over 3, and then you'd have to divide by the negative 1/3. Divide by negative 1/3, you flip and multiply, that becomes a times negative 3. Okay, that's u times v. That's going to be negative 3x e to the negative x over 3, minus the integral of v, negative 3 e to the negative x over 3, du, which is dx. That's negative 3x e to the negative x over 3. Minus and a minus is a plus. But then what happens when I integrate 3e to the negative x over 3? I get e to the negative x over 3 plus c. You missed a times by something. You got to multiply by 3 again, because when you integrate this, you're going to have e to the negative x over 3, but then you have to divide by negative 1/3. When you divide by negative 1/3, you flip and multiply by 3, so that's going to be negative 9 e to the x over 3. It would be a negative, because I had a negative and a negative. Those two negatives made a positive, and then when I integrate, I got to multiply by another negative 3, so I actually get 3 negatives.
There would be still a negative on top. Is that what you said?
Oh, that negative right there?
Yeah.
Yeah, that negative right there, absolutely. Thank you. Is that the one you meant? Yeah. Okay, yes. Too many minuses there. I moved up. Technically, we should have a plus c, but I'm not worried about the plus c because now I'm going to jump back up here and I got to plug my numbers in. I'm going to have the limit as b goes to infinity. Negative 3x e to the negative x over 3 plus negative 9 e to the negative x over 3 I got to plug b in, I got to plug 0 in, and then I got to take my limit. My Lord, yes. Limit as b goes to infinity. Negative 3b times e to the negative b over 3 minus 9e to the negative b over 3. That's what I get when I plug in b. Minus, I plug in 0, I get 0, because I got a 0 right there, minus 9. Because e to the 0 is 1. Okay, now what happens? What's the limit as b goes to infinity of negative 3b times e to the negative b over 3? Well, when b goes to infinity, what happens to negative 3b? It gets close to negative infinity. When b gets close to infinity, what happens to this e to the negative b over 3? Not negative infinity. Not positive infinity. It's halfway in between. It's 0. Why is it 0? What's that negative power going to do? That negative power drops it to the bottom. So you're going to have 1 over e to that power, e to that really, really big power. That's 1 over something really big. That's 0. So this is infinity, but that one's 0. How do you take the limit when you get the infinity times 0 form? Sometimes it's 0. Sometimes it's infinity. Sometimes it's any number in between. It's a L'Hopital's rule problem. This is why we did L'Hopital's rule. Except L'Hopital's rule, infinity times 0 is not one of L'Hopital's forms. So what do I have to do? I've got to take that e and drop it to the bottom. Then I'm going to be the form infinity over infinity. All right, so let's come back to that one. That one was not nice. What about this next one? 9e to the negative b over 3. What happens as b goes to infinity? That one's 0. All right, so this one's going to be 0. We're almost done. We've got the limit. As b goes to infinity of negative 3b over e to the negative b over 3 plus 9. Forget about that minus and the minus 9 there, plus 9. All right, now we're in a L'Hopital's rule form. This is infinity over infinity, so what do I do? Take the derivative. This is going to be the limit as b goes to infinity. What's the derivative of negative 3b? Negative 3. Divided by, what's the derivative of e to the negative b over 3? Close. Negative 1/3 e to the negative b over 3. Because it's e to the negative b over 3, then you take the derivative of the power. Plus 9.
Wouldn't the power of the e be positive after you move it to the bottom?
Oh, sure. Thank you. Absolutely. Power of e should be positive now that I moved it to the bottom. Absolutely. Just drop it to the bottom. Yeah, you can't just drop it to the bottom. When you drop it to the bottom, the power changes. That's right. Now I think we're done though. What's this limit now?
1 over.
Well, this is a number on top. What happens when b gets really, really big? What happens to e to the b over 3? It gets really, really big. So it's a number divided by something really, really big. Approaches 0. 0 plus 9 is 9. Okay, so that's how L'Hopital's rule gets incorporated with some of these problems.
So it was okay that it was in the form, like negative infinity over.
What's that?
What was the top in the limit of negative? Like before we had the derivative, was it negative infinity over infinity?
It was negative infinity over infinity,
So
but that's also a L'Hopital's form. It can be positive infinity or negative infinity on top. It can be positive or negative infinity on bottom. That doesn't matter. It's either got to be 0 over 0 or one of the infinities over one of the infinities.
How does the negative 9e to the negative b thirds change to 0?
When b gets really, really big, this is 9 over e to the b over 3. So when b gets really, really big, this is a number. And then this gets really, really big. A number divided by something really, really big gets close to 0. So that's how that one just disappeared. Other questions? All right, let's see. Do they have one here that has a negative infinity in it? I only see one. Guess we do that one. The integral from negative infinity to positive infinity of 4 over 16 plus x squared dx. All right, this one we got to split into two integrals. It's going to be the integral from negative infinity to, we pick our favorite number. We're going to use 0. Anything special about 0? Could you use any other number you wanted to? It is the midpoint, that's true. Other than that, anything special about it? Yeah, usually you want to use 0 because usually 0 is a very easy number to plug in. That's why I almost always use 0 on these. I would use 0. Okay, so we're going to split that one into two integrals. And then we've got to do limits for each of these. So the one on the left is going to be the limit as a goes to minus infinity, the integral from a to 0 of 4 over 16 plus x squared dx. Plus, the second one is going to be the limit as b goes to infinity, integral 0 to b of 4 over 16 plus x squared dx. So notice we always use the letter a when we're putting something for our lower bound, and we always use b when we substitute for our upper bound. So it's the integral from a to b. This is the limit as a goes to negative infinity. What's the antiderivative of 4 over 16 plus x squared? Arctangent of 4 times 1 over 4 arctangent of 4x. So it's 1 over a arctan ax, I believe. Yes? No? There's an x over a inside of here.
Get your card out, Adam.
I think it's x over a. So it should be x over 4. And then we got to evaluate at a and 0. Then we're going to have plus. The good news is this is the exact same integral, 4 over 4. Arctan of x over 4. Evaluate at 0 and b. And we need the limit as b goes to infinity. All right, well, what happens as a goes to negative infinity? What's the arctangent of a over 4 when a goes to negative infinity? What's the arctangent of negative infinity, basically? What's the tangent graph look like? It has some of these things. These things are asymptotes. And it looks like this in between. So this is the tangent graph. Where are these asymptotes? Pi over 2 and negative pi over 2. So, arc tangent going to negative infinity means we're going this way. What are we getting close to? Negative pi over 2. Oops, that's the wrong thing though, right? I should plug in 0 first, shouldn't I? What's the arc tangent of 0? 0. And then minus, I plug a in and I take that limit. It's 0 minus negative pi over 2, which is pi over 2. Plus, I plug b in, I got the arc tangent of b over 4, and I'm going to let b go to infinity. It's going to be pi over 2, because now we're going this way. Our tangent is going to infinity, which means our value is going to pi over 2. Minus, I plug 0 in, the arc tangent of 0 is 0, so the answer is pi. Questions on that one?